Hey everybody, welcome back. So today we're going to finish up chapter 7.2. Today's lesson is a little bit shorter than the one from yesterday. So today's topic is again, what affects the margin of error? And I wanted to talk about some practical issues like non-response bias, undercoverage bias, and response bias that can affect the interpretation of the confidence interval. All right. Now, what affects a margin of error? So, when we calculate a confidence interval, we include the margin of error because we expect the value of the point estimate to vary somewhat from the parameter. However, margin of error accounts for only the variability that we expect from random sampling. Okay, so that's a very, very key idea. If I told you to go take a survey of how many students at JFK have AirPods, and I had every single person go out and do this, I'd probably get different answers from most students in the class. And that's totally fine. That's just natural sampling variability. Now, just be careful, again, because the margin of error does not account for any sources of bias. Okay, so bias is not accounted for in the data collection process. So that, although you see the word error, you think maybe there was something that the people who conducted the survey did incorrectly. That's actually not part of margin of error. All right, let's look at this problem that we talked about yesterday. And what I really wanted to do was look at C. As we talked about A and B yesterday, what would happen to the length of the interval if the confidence level goes up. So again, when the level goes up, your margin of error goes up along with it. Here we said when sample size goes up, your margin of error goes down. But I want to talk about this problem here, which is C. And it says describe one potential source of bias in Ellery's study that is not accounted for by the margin of error. Okay, again, let me go back to chapter 3 when we first talk about what bias was. So the design of a statistical study shows bias if it is very likely to underestimate or overestimate the value you want to know. And it's not just bad luck. Okay, there's just a systematic flaw to the way you're collecting your data, and it causes you to underestimate or overestimate this value. Okay, and there's these different types of bias, such as undercoverage, and then there's non-response. So undercoverage is when you just make it less likely that someone can be chosen or cannot be in the sample. Non-response is when you choose someone and they just refuse to participate. And then response bias is a much more broad term, and it covers a lot of different types of bias. As you can see, there's a systematic pattern of inaccurate answers to a survey question, and that could be due to how the question is asked, what information is provided or not provided with the question, characteristics of the interviewer, lack of anonymity, having your respondents lie, and then just the fact that your respondents may not remember information accurately. Okay, so let's go back to our topic here. And in this question, if you read the context here, Ellery has students state their GPA aloud. Okay, so that may cause some issues, and that may cause students to lie because, what student would want to give their GPA if it's on the low side? And maybe some students with high GPAs may be ashamed that they're smart and intelligent students. So who knows? But our solution here is the margin of error doesn't account for the fact that many students may lie about their GPAs when having to respond without anonymity. The mean GPA for all students is probably going to be less than 3.14. Okay, so if you're asking students out loud to tell their GPAs, you're probably going to get an inflated number. In other words, an overestimate. And this sounds like response bias. It just sounds like the way that the data was collected was not done in the most ideal way. All right, a couple more examples real quick. Actually, I want you to try this out. There's just a couple more problems for you to try out, and then that's going to be it for today. So here, a local town council is considering a proposal to build a large department store within the town borders. A local resident is against the proposal and conducts a survey of town residents. Okay, so this person's already has a vested interest and they just don't want this department store due to traffic most likely and other factors. She selects a random sample of residents and asks them, are you in favor of a new department store in town which would create traffic delays? Please answer yes or no. Of the 240 residents surveyed, 211 residents responded no. All right, so there's a key phrase in here, which would create traffic delays. Okay, that's some information that's given that is leading the person to answer in a particular way. So, based on the sample, the resident claimed that she was 95% confident that the interval from 0.84 to 0.92 captures the true proportion of residents who are against building the new store. There's our confidence interval interpretation. Describe one potential source of bias in this survey that is not accounted for by the margin of error. Okay, pause the video, try it out, check back when you're done. All right, so our solution is that the wording of the question is unfair. It's not clear if the residents who responded no are against the store itself or against traffic delays. Because that other traffic portion was thrown in to the question about having the department store, that's could be a possibility. Also, it is plausible that adding negative information about the store influenced people to vote no. So you get your classic response bias here. Keep in mind, there's not one answer for this. There may be some things that you think about that are not listed here, or as you're doing your homework, there may be other factors. You can go ahead and mention whatever you feel contributes to this overestimate or underestimate. Whatever that bias is occurring, you can talk about it. But here, this is our solution from our textbook. And again, you may not get the exact same thing, but whatever you feel contributes, you can also list. All right, one last problem here. Principal of a large high school wants to know how many hours students spend doing homework during a typical week. 100 students were randomly selected, and the principal personally interviewed each student regarding their homework habits, including how many hours they spent doing homework in a typical week. So imagine Dr. Chavez calls you in. He picks 100 randomly selected students from Kennedy High School, calls you in and asks you about your homework habits. Might be a very intimidating situation, right? But based on the sample, the principal determines that a 90% confidence interval for the mean number of hours doing homework for all students is 2.3 to 4.1. So describe one potential source of bias in the study that's not accounted for by this margin of error. So go ahead and pause the video, write out your response, and check back once you are finished. All right, here is a sample solution. So having the principal interview students may intimidate them and influence their responses. As a result, they may lie, and they will most likely give a higher number of homework hours than they might otherwise if the survey was just anonymously done. So there's probably going to be an overestimate of the number of hours that students spend doing homework. And again, you have your typical classic response bias scenario. All right, so that pretty much wraps it up. Let me show you the slide of the different types of bias for you to refer to here one more time. So we've got undercoverage bias, or bias that leads from undercoverage, non-response bias, response bias. These are different types. This is way back in chapter 3, so if you still have your notes from back then, you can go ahead and review that as well. And that pretty much wraps it up for today. So if you guys have any questions, please let me know. Send me a Google Classroom message or Schoology message, and have a great day, everyone.